Okay, so in this video, I'm going to teach you about equations of circles and then also like how to graph them. So just to be sure, so this is a circle. So it's the white shape here. And so it has a center, so that's this green point here. And then from the center to the edge of the circle, that's called the radius. And if you were to draw a line straight through the center, that would be the circumference. And we want to think about a circle in the context of being on a graph in this video. So we're going to kind of change the way that we think about this just a little bit. So the center, I'm going to think of the center as a point HK. HK is going to refer to the center. And then let me just draw the radius over here for a second. And I want to think about a question here. So let's say that I have this random point xy, and I say to you, I want to know what is this distance. And, you know, if you don't know what the radius is, you could say, oh, well, if I know what HK is and I know what XY is, I could use the distance formula to figure that out. So I could bust out the distance formula, as you see here. And so the thing is, if I calculate this distance is really just the radius, right? So this distance here is still the radius. So I could replace, instead of calling it D, we could be a little bit more specific this time and instead call it R. So R for radius, because that's what this particular distance represents, right? And so now what I want to do with this equation here is I want to square both sides, and this is going somewhere. So if I square both sides, I get this equation here. And this is important because this equation, this is one way to write the equation of a circle. So this right here, we like just created how do you get to that equation of a circle. So this is what's known as the center radius form of an equation of a circle. So it's x minus h squared plus y minus k squared that equals r squared. HK always stands for the center, R stands for the radius. So just to get us used to playing around with this formula a little bit, why don't we try to find the center radius form for the following. So I'm going to give you a center and I'm going to give you a radius. And so we will bust out that form so that x minus h squared plus y minus k squared equals r squared form. We're basically just going to fill this in. So just trying to get you used to using this equation. So one thing I recommend if you're playing along at home here is that you actually force yourself to write this equation out. It will help you to memorize it faster, okay? So, all right, so now I'm going to plug in my center. So if I plug in my center, so here's everything that goes into plugging in the center. And then of course I want to simplify this as much as possible. So the center radius form here would be x plus 2 squared plus, oops, and I forgot the squared there, y minus 3 squared equals 16. So that would be the equation, the center radius form of an equation of a circle. Okay, so why don't you try this one and then just hit play when you think you've got it. So remember, math is not a spectator sport, so just give it a try, hit play when you're ready. All right, so once again, I want to use that center radius form, which I've written out here. So if I just kind of plug everything in, so I have x minus 0 squared plus y minus negative 1 squared, and that's going to equal 2 squared. So this simplifies to x squared plus y plus 1 squared equals 4. So that would be the center radius form in this case. Okay, so now that we kind of have a sense of how to use this equation, let's try graphing. If you have this format of the circle, it's pretty easy to graph actually. So, all right, I've got x minus 1 squared plus y plus 3 squared equals 4. Okay, so my center, so let's see, I'll just note that. So my center is going to be what? So if it's minus 1, then the center must be just positive 1, right? So it's kind of like the opposite sign. And then so it'd be 1, negative 3. And then the r, so remember, this is r squared. So if I take the square root of 4, my r will be equal to 2. Okay, so what I need to do is I need to graph 1, negative 3. So 1, negative 3, bada bing. And then I want to plot a couple points around it to signify the radius so that when I draw it, I have, you know, kind of a guideline. So let's see, from here, I'm going to draw out in each direction. So 2 out this way, 2 out this way. So I'm counting out that radius, 2 out this way, and 2 down this way. All right, now here's the worst part of this video for me. I always get a lot of anxiety of having to draw a circle in front of all of you, but let's see how I do. Oftentimes it comes out a little squarish, but let's see. Oh, yeah. Okay, well, not the best, not a perfect circle. Again, I'm under the gun here, but okay, so you get the idea, right? So that is how you would graph a circle. All right, so why don't you try this one? Just give it a go. Hit play when you think you've got it. So in this case, so since I have no like plus or minus, my center in this case would just be 0, 0, and my radius would be equal to 3. So there's my center, and then I can count out 1, 2, 3 in each direction, and then the moment of truth. I think this one's gonna be really terrible. Okay, well, use your imagination. Let's pretend that I'm a great circle drawer, okay? All right, so that is how you graph circles. I think you get the idea, right? All right, so I want to keep going with this idea now, and now I want to tell you how, I want to explain to you another form of the circle. So what we're going to do is we're going to expand this equation. And so what I mean by expand is that this x minus 1 squared and this y plus 3 squared, I'm literally going to just do that operation. So I'm going to color code it so that you could follow what I did. So I'm going to expand x minus 1 squared and y plus 3 squared. So if I expand this part here, I get x squared minus 2x plus 1. If I expand this part here, I'm left with y squared plus 6y plus 9, and then we still just have this whole thing equals 4. So let's keep going with this now, and let's just add any like terms that we can, which on the left side, I can really just add the 1 and the 9, right? So if I add the 1 and the 9, now this becomes a 10, so I've got x squared minus 2x plus y squared plus 6y plus 10 equals 4. And now what I want to do is I want to get rid of the 4's, so I would like this whole equation to be equal to 0. So I'll subtract the 4 from each side, as you see here. And so that's going to leave me with now x squared plus y squared minus 2x plus 6y plus 6 equals 0. So I really didn't do like a whole lot, right? I like expanded these, and then just where I saw like numbers, I just like collected them together. But this part right here is what's known as the general form. So it's very much related to kind of that center radius form we were working with. It's just now if we expand it, that's what makes the general form. The general form of an equation of a circle looks like this. It's x squared plus y squared plus dx plus ey plus f equals 0, where d, e, and f are real numbers. Okay, so that's the general form. It's not as user-friendly, right? So if I just gave you this form, it's kind of hard to know what the center is. So actually, like, we can deal with this form, but it's like not great for graphing. So what happens a lot is we like unravel it to make it something more useful. Because that first equation I showed you, right, that was like great. We loved that. That was nice. This, maybe not so much. But a lot of things work like this, so we have to know how to like live in a world where the general form exists, if you will. Now, the other thing I want to tell you is that the general form can be a circle, but it could also be a point or non-existent. So there's some issues with having this form that we're just going to have to learn how to deal with, and I'm going to show you how to deal with those things. Now, to use the general form, before I show you how to use it, because actually what you're going to want to do is you're going to want to put the general form back into that first center radius form. So what's helpful is to review completing the square. So we're just going to have a crash course review on this. I have other videos where I like teach this, so if you have no idea what I'm talking about, don't worry, I've got videos I can teach you, it's no problem, but I'm just gonna really quickly review it here. Okay, so I've got this quadratic, and I just want to review how to solve by completing the square. So I've got x squared minus 6x plus 4 equals 0. All right, now there's a couple different ways that you can do this. The way that I tend to do this is I usually like to have the variables on one side and then the numbers on another. But you could do this in a lot of different ways. So I will just run with it like I usually do it. And okay, so now what we're going to do is we're going to take whatever is attached to the x, that becomes my b. So my b is equal to -6, and this kicks off a whole process. Once you identify b, then you want to identify what is half b. Half of b would be -3. And then whatever the answer to that is, you want to square them. So if I square -3, I get 9. Okay, And so with that 9, now what you want to do is you want to take that equation and you want to keep it balanced. So you add the 9 to both sides like you see here. And then what this allows you to do is then you can factor the left side as a perfect square. So this would factor as x minus 3 squared equals 5. Now one thing that I do want to point out, this minus 3, this whatever you put here, that's always equivalent to whatever your half b is. Okay, and then from here, so this is not really relevant after this, but you can continue to use the square root property to solve for this. But so I'm actually not going to finish this, but this is the big thing that I wanted to show you, was how to complete the square and kind of set that up, okay? So now I'm going to show you how to write the following in center radius form to help you decide if what we're working with is a circle or not. Okay, so the idea here is that I can give you a general form equation and that you can do something with it. And this requires a little bit of finesse, and you got to use completing the square. So a couple different ways that you can do this. So first and foremost, what you're going to want is you're going to want to have your x's together and your y's together. Now we have that. My x's are together, my y's are together, we're all good. Actually, let me use a different color here. Okay, so now what I want to do is I want to complete the square twice. So maybe I'll just note this. I want to complete the square for each pair. Okay, so let's go ahead and do that. So starting with the x's, so my b in this case is the -4. And remember, this sets off a whole process. So then I have to find what my half b is, which is -2. And then I square that, so -2 squared is going to be equal to 4. Okay, and then I have to do it again for the y's. So now, on the y's, what's in that b position, so what's attached to the non-squared variable is 8. So this will be 8. What is half of 8? Half of 8 is 4. And then what is 4 squared? It's 16. Okay, so now what we're going to do is we're going to take each of these. So let's see, I'm going to just note that my half b squared here was 4 and my half b squared here was 16, and I'm going to clear some space. Now, different books go different ways with things, but I will tell you the way that I prefer to do this. This 44 is just kind of like extra noise right now, so I just want to move it to the other side, and that's just kind of the way that I want to think about this. So what I'm going to do is, let me, I don't want to go too fast here, so let me first also write this as just like this. Okay, and so now what I want to do is I want to add that half b squared to each of these, but I also want to add that to the other side. So I personally like just doing the same operation on all sides. So if you read like some other books, they talk about like adding and subtracting on the same side. The equivalent of that would be just taking all the numbers, like the extra numbers that you have, and putting them on the other side. So there's a reason why I guess I like doing it like this. It feels like completing the square, and I don't get too confused from it. Also, you're going to see another benefit of this in a moment. So it's best to just kind of move everything to this side. It really is the best practice. All right, so anyways, so let me write this all out more clearly. If it's your first time seeing this, it can be very overwhelming. So I want to have as much detail as possible for you. All right, so now we're pretty close actually. So now what I want to do is I want to take each one of these groups, and each of these groups I want to factor each as a perfect square. And so if you are taking notes here, and if you're playing along at home, so you have that half b to help you figure out how to factor these. So let me clear some space. So this guy right here is going to factor as x minus 2 squared. And this guy is going to be x plus 4 squared equals 64. And oh my god, look at what we did. So, all right, now we have this center radius form. So it's very helpful to get that like one number to the other side, because now boom, we're done. We're good to go. So that is how we got in a center radius form, and then we can graph that. So let me clear some space. All right, and so I can graph that all day, every day now. So let me bring my graph paper up. Okay, so I have a little bit of a scaling issue here. So each tick mark on my graph is going to represent 2. Okay, so my center is 2, -4. So 2, -4 by my graphing standards is here. And then my radius, so this is 64, so the square root of 64 is 8, so my radius is 8. So now I just want to count out 8 in each direction. So let's see, this is 2, 4, 6, 8, 2, 4, 6, 8. Let's see, 2, 4, 6, 8, yeah. 2, 4, 6, 8, and 2, 4, 6, 8. Okay, and so now I can draw my football shaped circle because my scale is all messed up. But again, you get the idea. Okay, so now I've got one more example for you, and this is one where I want you now to try what we were just talking about. So I want you to notice this is in general form. So the first thing that you're going to want to do here is just get everything in its right place, like the Radiohead song. So I've got x squared plus 2x plus y squared minus 6y equals -14. So just to point out what I've done here, I bunched the x's together, the y's together, and then that other number I sent to the other side. Okay, so now what I think you should do is I think you should try to finish this problem on your own. And I will warn you, something weird is going to happen. So push forward as far as you can. It won't happen. The weird thing won't happen till the end, but then we can talk about it. But I want you to try completing the square. Math is not a spectator sport. You will get more out of this video if you try it on your own. Hit play when you're ready. Okay, so now I'm going to go ahead and do my completing the square magic. So in this case, my b is equal to 2. Therefore, my half b is equal to 1. And my half b squared is still equal to 1. And then for this other pair, my b is equal to -6, my half b is equal to -3, and my half b squared is equal to 9. All right, so now it's this 1 and 9 that I want to add to each part of the equation. So I've got x squared plus 2x, and then I'm going to add in that half b squared of 1. And then I have the y squared minus the 6y, and I'm going to add in that 9. Now, because I've added a 1 and a 9 to one side of the equation, the reason why we add it to the other side is that's the only way you can keep the equation balanced, right? Otherwise, you've got a lopsided equation. You added numbers to one side, but not to the other, so then it would no longer be equal. All right, so now I can go ahead and factor, right? So this x squared plus 2x plus 1, that factors as x plus 1 squared. And the y squared minus 6y plus 9 will factor as y minus 3. Now once again, just to point this out, if you ever get lost when you're trying to factor this, it's always whatever your 1/2 b is. You can always just refer back to that. Okay, and so all of that now is going to be equal to -4. And now, I'm sure you said at this point, zoinks. I hope you said zoinks. All right, so what's the problem? What is this? You can't have a negative radius. Oh my God, did we do it wrong? We did not do it wrong. This is a thing that can happen with the general form, and you won't know it until you get it back into the center radius form. So a negative radius just doesn't make any sense, right? So this equation actually, this graph does not exist, so we don't have to graph it. Now, I want to tell you one other thing. If you get something like a center radius form that comes out to something like this, the thing that matters here is that you get a 0. So you can't have a circle with radius 0, but this does actually mean something. A circle with radius 0, the center here is the point. So let's see, the center in this equation would be -3, 4, but this actually is the graph. So this is it. This is just a point. So this is just a point. So that's the other thing that can happen when you're working with these. Now, in the interest of keeping this video shorter, those are all the examples that I'm going to do, but I have another video with more examples on the general form if you feel like you need to watch a couple more. So don't worry, I've got a handful more that you can check out. So I'll drop a link to that in the description, and otherwise I'm just going to call it here with this video. So if you found this helpful, consider leaving a like or commenting or hitting that subscribe button. And otherwise, I will talk to you guys next time. Thanks for watching.